Hello, friends. Good evening and welcome to Eastern Academy. We are into embedded system programming, and today we are going to discuss about microprocessor. This is session one, and my name is Balaji Seshadri, and I have given my WhatsApp number 90429 14720. If you want any doubts, anything, don't hesitate to contact me on this WhatsApp number or send me a mail on this easonelectronics@gmail.com. I'm always approachable. Okay, so let us getting into the thing microprocessor, what it is, because the whole our course embedded system programming is microprocessor. That's it. So you can call wherever microprocessor is used in electronics. All those things are coming under the embedded system. That's it. Simple as simple as that. If some system in electronics, electronics have three branches. One is called IC design, one is called embedded system, one is called board design. So if any circuit uses microprocessor, then that's called embedded system. That's it, simple. So we will discuss about board design and VLSI at the end of this embedded session, not now. So, and today we will talk about this session. In this session, we will talk about introduction. Okay, so what is this microprocessor? And let us try to, normally there are multiple ways people approach the every topic. And normally we approach from known to unknown. So what you know. So every day what interaction, what we know is a simple human. So let us try to compare the human versus, but may not be so perfect, but it will give you the small idea. It will give you the small idea to understand about what is microprocessor. That's it. So let us take a human being. Okay. And we know that the whole human being, every part is important. Every single part is important. Your leg, hands, your stomach, heart, everything. But ultimately, everything is controlled by the head. So you know that head is the very critical part. So we are going to discuss about the head now. Okay. And inside the head, okay, you have so many parts: nose, mouth, ears, okay, everything, but eyes and all. But we are going to discuss about what is inside your head. That's about your brain. Okay. And so let us take only the brain out of the head. So now, if you zoom the brain, it has so many. It's a collection of we call one brain, but it is a collection of so many parts. Am I right? That's a trick of the your wonderful assembly of brain. Then let us take one by one out. And that this is one part, and this is another part. We are not teaching biology, so I'm not going to discuss about all the names of the parts or anything, nothing. Why I have displayed the part is to give you a small idea. And all these parts are connected through nerves. You know that they're all connected through nerves. And the communication is through neurons. That's fine. I'm not getting into the biological or biomedical things. Now, one of the parts out of this is very important in this. This part is called process part. This part does all the processing of your brain. And this part is the one which holds the memory. All your memory things are remembered at this part. This is called frontal lobe. This is called temporal lobe. And you have so many lobes. This part controls your hands and legs. This part control your eyes. Okay, each part, this part connected to your heart. Okay, they call cerebellum. And you have so many parts. And let us not worry, we take only one part. The whole brain, we take only one part. That part is this frontal lobe. And later we will use temporal lobe. Okay. The frontal lobe is the one which does the processing, but it has a another intelligent thing called thinking, which we don't have. We are not worried about. We are just taking about only processing part. So this is one of the part of your brain. Your frontal lobe is not brain. Frontal lobe is one of the part of your brain. Now, what we are going to do is this. We are going to morph the frontal lobe as a microprocessor. That's it. Both are same. What the frontal lobe does and what the microprocessor does are same. Now, the microprocessor is, what is that? It is nothing but it has so many pins. Am I right? This is a component manufactured by the companies. So you can call it a frontal lobe is manufactured. So one of the part of your brain. We will discuss what is brain later. Brain is normally compared with a microcontroller or SOC. Brain is compared with SOC or microcontroller, both are same. Microcontroller and SOC both are same. When I use the microcontroller in mobile phones or laptops, we call that as a SOC. That's it. If I use the microcontroller in electronics, I call it as a microcontroller. That's the same thing. Now, this microprocessor has so many pins to connect to the out. We connect everything through wires. That is why these pins are the one which connect your microprocessor inside to the outside world. Okay. Now, let us go through inside microprocessor. Okay, that's very important. So let us see what it is. It has a small silicon, okay, metal, and the circuits are there, and the wires are taken out, and the wires are connected to the pins through this. Okay, this is what happening inside the IC manufacturing unit. Okay, then let us remove this top level pins. Let us talk about only the bottom one. So what is inside? This is a base. This black one is a base over which you put the silicon. Then if you see that only that part, the silicon part, forget about all the other things. Now we take only the small silicon portion. Okay, a small. This is what the part where your circuits are placed inside. Okay, that if you want, we will discuss in our electronics session, the electrical and electronics session. We will discuss about how this is manufactured. Don't worry about that. Right now, don't worry about those things. Now, this part is what this. See that internally you have so many circuits. Okay, if you zoom still big, it will be so. This is what they put it inside the silicon. Okay, how they do it? Let us do a small thing. Let us have a small intro. This is what the circuits. All the green ones and blue ones are wires, and all the yellow and pink ones are silicon. Okay, that's why they make the process and do that. Don't this all we will discuss in our electrical and electronics in depth. Don't right now worry about this. See, this is what the trick. You have to be understand what is your role. You are not going to be the car engine designer. You are going to drive the car. Embedded system is driving a car. Okay, like using the microprocessor. Understand? Designing the microprocessor is the other batch. That is called VLSI. Okay, so don't get confused between these two fields. Of course, we will know that we will discuss what is inside everything. I'm not going to say that, no, I'm not discussed. But initially, as a driver, if you say that, if I don't understand how the IC engine works, if I don't understand, if I put the brake, how the brake is working, then you will never get a driver. So as a driver, you should know what are the operation I should do to drive the car. That's it. That's a successful, be a successful driver first. Then once you become a successful driver, then learn it, how the car is working. Fine, that's good. Okay, but don't get confused. Now let us take only one. I have so many circuits and I'll take only one circuit now. And all these circuits are nothing but and or not. Like we have in our mathematics, we have 4 operations: addition, subtraction, multiplication, division. But the whole microprocessor is built with these three gates, and, or, and not. Okay, this we are going to discuss in depth in our digital electronics session in the coming days. Okay, right now, don't worry about that. Right now, as I told you that the top level we understand, this microprocessor circuits are built using these gates. Okay, and this is what a simple circuit of only one gate. This is one gate I've drawn is a one gate, and this is the input, and these are outputs out. Okay, so this is a simple circuit. Don't worry about that. Next, and this is about a simple gate, and, or, not. These three, like how in the schools they teach you addition, subtraction, multiplication, division. If you know these three gates successfully, clearly, and you know, I know that most of you know that, but the only problem is you don't know how these gates are used so effective, such a way that I am sitting in Earth controlling a satellite in Mars, or Land Rover in the Mars. How I am going to move? It's all very easy. That is what our course. Our course is all about these electronic controls. How we are going to do that. So don't leave it till you learn it. It's your responsibility to learn it. It's my responsibility to make you to learn, and your responsibility is to learn. We both are synchronized. Both are to be synchronized. Okay. Now, this part is what very bottom level. So I take that the P substrate is nothing but some sort of silicon added some material. We will be knowing that, but I'm not going in depth. That we will discuss about all this P, N, all these things, N well, everything, and P well, all these things in our electronics class. Not now. This is the microprocessor session. But I have to tell you that what is the bottom level. Okay. But you come here, this is a one component which turned the whole world. This is the invention of the century, last century. 20th century invention is called this component called transistor. And we built all this and, or, and not gate using this transistor. That's it. Your microprocessor is full of transistors, nothing more than that. Your microprocessor is full of transistor. How the transistor is? The transistor is used to build the gates, and the gates are used to build the logics, and finally the logics are used to build your microprocessor. Now let us go to the next. And the people, those who invented the transistor, got the Nobel Prize, and this is the biggest invention. Afterwards, the growth of the electronics was very exponential. It is giving you the life for most thousands and thousands of engineers. Okay, so we have to be thankful for the people and the Bell laboratories. Next, now this microprocessor internal VC. Okay, what is that? There are 4 parts internally. One is called process, which does your addition, subtraction, multiplication. That's called ALU. We'll discuss thoroughly. Don't worry. This is only a very top level picture. The top level, I wanted to give you what is inside. Then we will go in depth. And the memory, we have in our brain, we have a small memory. If I ask you to add 4 plus 5, what do? You remember 4 and 5, and you add, and you tell me 9. Am I right? So you have a small memory, but we call them as a register. And interface is the one which this microprocessor is talking to the external world. But these are all the 3: process, memory, and control. All the 3 are happening internally to the chip, internally to your frontal lobe. But your frontal lobe is connected with the outside components through the nerves. That is what this interface. How your internal silicon is connected to outside world. That is called bus interface unit. That's called BAU, or we call it the interface. Okay, so now we have slightly compared your brain with the microprocessor. Understand? Okay, now let us see that how microprocessor functions, how we are going to use it. The two have to be known. How microprocessor functions and how we are going to use it. That's most important. If you know that how the microprocessor function, if you don't know how to use it, no company wants you. Okay. If you know how to use the microprocessor effectively, every company wants you. That is what your embedded system programming. Okay. That is what your embedded system programming is all about. So the main central part of your embedded system is microprocessor. As I told you that you can say in one word, if a system use microprocessor, that is embedded system. That's it. Nothing more than that. Okay, in electronics. Of course, you have a computer that uses a microprocessor. We don't call it embedded system because it's a general purpose computing engine. But if you use it on electronics, so that we will discuss a small debate. What is the difference between computer and embedded system? We will discuss these things later. Okay, first today's session is about microprocessor. So let us, as usual, after the intro, to explain more depth, let us go to the board. Okay. I hope I would have given a small idea about what is. So it is not brain. Please understand, this is not brain. This is one of the part of the brain. Okay. Now, let us talk about this is a microprocessor, which has a small block called process. What it does very simple. Addition. It does addition, subtraction, multiplication, division. It knows how to do this. Then it does another three. Or, and, or not. That's why we call this as a ALU, arithmetic and logic unit, arithmetic logic unit. And this microprocessor we can call it a MUP. It's a very famous one. It's a very, very simple component. Please understand. Even I will go in depth later. I will go later, not this class and not later. Once you have familiar with this, how the microprocessor work, I can explain to you. Then we have a small unit called memory. A small memory. But as I told you that we call this as a what? Register. Both are same. Please understand. There is a lot of confusion here in electronics. We have a terminology called latch. We have a terminology called register. We have a terminology called memory. We have a terminology called storage. See, so many things for everything. All are coming under memory. So we have so many divisions. So people normally get confused between memory and storage, and people get confused with register and memory. But to be frank, all of them are same. But depends on where you use it, how do you use it. They had given it's all to differentiate. To differentiate, they had given a. So we have a thing, lake, river, pond, well, everywhere water. But you know that if I say a lake, you know that it's a bigger storage. A sea, it has water. It's a big, and you know river, it is running. So everywhere water storage, but we are giving them different name. Here same thing. All are memory. A latch is a memory. A register is a memory. A memory is a memory. In that sense, unfortunately, they keep the memory, it's a memory. And storage. Okay. So now, so this is called, as I mentioned to you, that compared to your brain, this is called frontal lobe. This is one of the part of your brain. Like, so there were three things involved. Please understand three things. One is called product. One is called system. One is called process. Please understand these differences. Process is the main one. Okay. Okay. That's why it's called, they put always in the middle, process. And surrounding the process, you have system. And surrounding this is, you have a product. In our embedded system programming, the process is going to be microprocessor. In your human brain, the process is frontal lobe. And system is nothing but your microcontroller or SoC in our embedded systems. Okay, because sometimes when you go a bigger embedded system, people use the word called SoC. Okay, SoC is not only used in computers. Nowadays, that's slowly getting into the electronics also, in embedded also. And the final one is product. What are you going to use the microcontroller? Any product. Could be a player, video player, TV, or video player, remote, anything. You can define any product. Product is top level. The product uses the system. Like that, in your system, you have a frontal lobe and the brain and all the other hands, everything. All the devices are controlled through this, not the microprocessor do not control you directly. So here what happens is this. So please don't get confused. This is, I told you, frontal lobe. Your frontal lobe is having a small memory. Like if I ask you 4 plus 5, you take 4 plus 5. What is happening is, this process can talk to only the local register. This process cannot talk to the outside world. So if you want to do anything, that has to come from outside to this local. You can call this as a local memory. Please understand. This is called local memory. That's all we call as a register. Okay. This outside one is actually called, in your brain, is called temporal lobe. Where, for example, your teacher taught you in the school how to multiply a 2-digit number. Am I right? Like yesterday we discussed 25 multiplied by 63. Your teacher taught you, hey, 5 into 3, 15, 5, 1. 2 into 3, 6, 1, 7. 6 into 5, 3, 0, 3. 2 into 6, 12 plus 3, 15. You add 5, 7, 5, 1. So you know the procedure. This procedure is stored here. If you know the procedure, then you know multiplication. If you don't know the procedure, you don't know the multiplication. Now, when somebody asks you to do this, okay, as I told you that, please understand, this is what the trick. You have a frontal lobe and you have another part in your brain, let us say, which is connecting your eyes. Okay, this part is communicating with your eyes and talk to your process unit, frontal lobe. This is your brain. That's why people say that there is some problem with the brain cell. You lost the control over your hand or control over your eyes, control your legs. It's because that particular part is having a problem, but your brain will be functioning, but the particular part is bad. So when you write on the board 2 plus 3, your eye sees that and give it to the frontal lobe. Understand? That's a trick. But then your guy decides, how do I process it? Then he goes and sees this. How this guy stores the memory, how it is taking, we don't know. But here we know, in microprocessor, this guy is using only gates and OR. And basically, it uses the transistor as a switch. So this whole microprocessor is full of only switches. That is what we are going to discuss. How your software, how your C programming is controlling the switches. At the end of the session, you should be thoroughly understand about that. But we have so many methods of discussion. This discussion is different method where we discuss top to bottom. Let us understand about microprocessor first. Then we will go how the microprocessor works. So this is a path. Microprocessor, digital electronics, and electrical. That's a way. Instead of going the other way. Because in the colleges everywhere, you learn the other way. That's why you always see everything as a much complicated way. This is the top level approach. So what happened? This guy, like a nerves in your brain, how the two parts are communicated with nerves. Here, they communicate through wires. They communicate with wires. The messages are passed there is between these things are all some messages, which I don't know. Sorry. Here, I know that we are passing through numbers. We are passing through numbers. That's it. Now, I have a wire. In a wire, how do I pass a number? Okay. It's a very simple. I have a battery. I have a bulb. I have a switch. If you want to pass a number 10, you press the switch 10 times. If you press the switch 10 times, then the bulb is going to be on and off 10 times. It could be how far it is, it doesn't matter. It could be 1 kilometer away. I can pass the number 10. Understand? But you know that if you want to pass the number 100, then I have to do 100 times. If you want the number 1000, I would do 1000 times. It will be very, very slow. Then only people have found so many methods. One other method is very simple. If I have a one wire, I will on or off. Off means 0, on means 1. I can put two numbers. If you have one wire and one bulb, I can convey from X to Y two numbers, 0 or 1. Then what they have done is I added one more wire. Two wires. Now two bulbs. Let's say one is red bulb, one is green bulb. Now both red and green are 0, 0 off. And green is off, red is on. Green is on, red is off. Green is on, red is on. There are 4 combinations. We give 0, 1, 2, 3. Understand? That is as simple as that. So what they have done, they add one more wire. Then blue. That means I get 3 wires. So I get 2 power 3. I can pass up to 0 to 7. Please understand, if I have here, I start from 0, not from 1. That is a very important area in this microprocessor world or in this digital world. So if I add one more wire, I can go up to 2 power 4, 16 numbers. So let us think of it. If I have 10 wires, I have to draw, I get bored. So what we do here is very simple way. I put /4. Instead of drawing 4 wires, I'll draw 1 wire, I put /4. That means that 4. Am I right? Instead of writing 1 lakh, I'll put 1 lakh. So simple. Instead of writing 1 crore, I put 1 C. So easy. Am I right? Instead of 1 million, I put 1 M. It's very easy. So we always try to put a shortcut. One other shortcut here is this called bus. It's a group of signals. That is what they communicate in the memory. Please understand what the microprocessor, there are two things. Please understand this. Microprocessor can do two activities. One is internal, other one is external. External. These are only two. Internally, it does process. Externally, it does storage. Store. Because I have very small memory. I cannot remember. That's why I store everything outside. Okay. There are multiple types of storages. Okay. Let's say I have a human being. As a frontal lobe, the brain, I have a small register. Then I have a temporal lobe. I have a memory. But this itself is limited. That's why I have a notebook. I store it on a notebook. Am I right? Same thing in your system computers. You have a microprocessor which has a register. Then the outside there is a IC called memory. And then you have a hard disk. You have so many things. SD card. You have a pen drive. You have a SSD. N number of things. That's called storage. So please try to not to get confused, but I'm trying to compare what is available. What do you know the terminologies? I hope most of you know about computers, other things. That's why I'm taking those things. So it's initially try to understand this, but slowly you will start forgetting other things. You get into the microprocessor fully in coming days. Okay. Now there are two things. You have to remember only this. How thing is. The moment I talk about microprocessor, it has two ports. One is called internal. Other one is called external. That's it. Internal, it does process. External, storing or reading. I store and read, or we don't normally call the reading as a store and load, or write and read. Both are same. Either store and load are same. Why they call load is this. What is happening is this. There's a confusion. In your case, human case, you differentiate between 75 and plus and 45. For you, these things are having a different. This is called number. This is called symbol. Am I right? But unfortunately, our man, microprocessor, who understands only number, his language is called number language. His name is called number language. So what he does is any number first he gets. If he gets the first number, 75, he treats the first number as a always instruction or operation. Like normally you have a convention like this. You write like this, 75 plus 43. But because you know that this is symbol. But what this here in the microprocessor is, you have to write like this, plus 75, 43. This operation has to come first. That's the only small convention difference between. So I write like this. Instead of 75 plus 43, I write like this, plus 75, 43. So this becomes 1, 2, 3. This is called operation. These are called operands. Okay. We call this language, this microprocessor language, machine language. We call this as a machine language, please. What your language is Hindi, English, Tamil or Malayalam or French or German. This microprocessor language is number language. That is called machine language. Both are same. It's actually a number language. And also the number language is speciality. This case number language is binary number. Okay, so we'll come in depth slowly. Don't worry about that. So what this guy does is like this. He has two set of wires. Let us assume that in every line on the memory, every line, okay, I store 8 bits. This is called 1 byte. I told you in the yesterday class itself, we have a general convention is byte, is a measurement. 1 gigabyte RAM means byte. Your hard disk is 500 gigabyte. Your pen drive is 32 gigabyte. Your SD card is 64 gigabyte. We always use byte as the measurement of memory. Okay, that is a standard. So same thing we are using now. Every line we are storing a byte. Understand? What this guy can do, this microprocessor is, he can read from any line. Let us say I have about 1000 lines, 0 to 1023. That is notebook. Understand, this is a notebook. Or you call memory. Okay, so this processor can read from the memory and he can able to do that. He can see, first of all, understand this microprocessor with the external. I told you there are two operations. One is internal. Go one by one slowly. Other one is external. There are two activities microprocessor can do. When I do the internal activity, I could do the process. How I do process? Between the process unit and the register. That's a process is nothing but the ALU. He does only arithmetic and logic unit. There are only very few operations. You will start surprising. The moment you start learning the microprocessor more and more, you'll be surprising. Hey, what is such a simple component is controlling the world? That's a trick. That is a trick. We all have to thank to one of the great man, Charles Babbage, who understood that this can be automated, the computing. Okay. Now, the trick here is, this is what internal. The external is read and write. That means that this microprocessor can read from a notebook, that memory. It can say that what line it is. This is a wire, set of wires. Assuming that I have 10 wires. You know that 2 power 10 means 1024. That is 0 to 1023. So using these 10 wires, this microprocessor can read from any of the line or write into any line. For writing or reading, he uses this set of wires, 8. So I have two directions. I can write or I can read. But this one I can only show. Address is unidirectional. So sorry, this wires. There are two set of wires. We call this set of wires as a address, because that is used to point the right location on the memory. And this set of wires, 8 wires, called data, because you are reading the content of the wire. Please understand, I have two set of wires. One set of wire is used to point the location where it is. Another set of wire is used to read or write the content. But how the guy will know that I want to write or read? For that, there are 2 more wires. That's it. You'll be very surprised. You'll be very, very surprised to know that this is what from 1971 to 2022, all the microprocessor does, nothing more than that. Please understand. It may be so simple, but that is what, nothing more than that. Okay. If you have any confusion here, anytime you can stop. Okay, don't mistake me. So I have a processor like a frontal lobe. It does the processing of addition, subtraction, multiplication, division, and or not. Take only 7 operations. We will discuss about other operations later. Let us not worry too much. Once you master the 7 operation, all the other, maybe few others are very few operations. We are going to, you will be very surprised. Only using this, we are doing everything. You do all the digital money, digital economy, digital control, everything, all IoT, all networking, everything because of this. You'll be surprised. If whatever level you want to go, you with me, I'll give you the maximum of this. Okay. And this guy can only do this. But what to add, everything is given by this guy. Okay. Now, this guy communicate with the outside world using the set of wires. Now, why I'm telling you now. One is called read wire, other one is called write. There are 4 wires. One is called address wires, a set. One is called read wires. One is called write wire. One is called data wire. That's it. Now, it's a very surprise one. I told you that read or write, that I will expand it now. Then you will surprise. The first operation is like this. Read from external memory to internal memory. Same way, second operation is write, one thing. Read from external memory and write to internal memory. Same way, the second operation is read from internal memory and write to external memory. You understand now? This guy, you'll be very surprised. Please understand. This is what all about your microprocessor, embedded system programming, everything is all about. If you understand these 2 lines, we have done. That is what we are going to discuss, how to implement these 2 in our whole embedded system programming, nothing more than that. Please let me be very, very clear now. Even if you ask me after 2 months only, this is what you will be surprising. We are going to do 2 activities. Read from external memory and write to the internal memory. That is called register. And read from internal memory and write to register. Understand? Now I can write like this. The first operation is like this. I can say I'm reading from external memory. We call load. We call that as the load. I can write it in full English itself. Load. To register. This R means register, internal memory. And from external memory, I have 2023 from anywhere, 512. This is external memory. Understand? Suppose internally, I have more than 1 register. I have R0, R1, R2, R3. I have three lines. I have 3 lines. I have a very small notebook with only 3 lines or 4 lines. Then I can go like this. R0. That's it. And instead of writing so big word, we make it so small. We write the word in a small cryptic way called LD. This is called load. So if I tell the microprocessor, hey, load from R0 from 52, he will do it. But how to tell? That I'll tell you next. That is what we're going to discuss next. Same way, the other one is store R1 to 856. That means that this guy understand, oh, I have to, whatever is there in my register in R1, that is also 8-bit. This, all of them are 8-bit. R0 is a 8-bit. R1 is a 8-bit. All of them are 8-bit storage. So this and this are same. Whether I can exactly copy this into the thing. Indirectly, I'm asking you to copy only. This is a copywriter. This microprocessor does only that. It's a very surprise. The whole invention is great, but the operation is very simple. Don't get confused. Okay, don't get confused about the operation. It's a very simple. We write in cryptic form. ST R1 856. You can have any combination, man. You can have any combination. You can say LD R0 98, LD R1 783, LD R2 431, LD R3 121, LD R4, 0. I can read from 0 also. So I can show LD R5, 1023. It's a maximum. I cannot, because I have only 10 wires. With 10 wires, 2 power 10 is 1024. That is 0 to 1023. Always, please understand, always let reduce one less, because we start from 0. And that's the thing. So please understand, forget about internal, all the things. The microprocessor is doing 2 activities always. One activity is as simple as that. That is, think of it. This is a very, very beauty of the system, and which is going to really make you to surprise that is such a small system is controlling everything. Whether you want to control the motor, whether you control the lights, or whether you control display, all are happening because of this. That is what we are going to discuss, how it is discussing. So this is connected to set of wires called address. I can have a set of wires 20. 2 power 20 means 1 million. That's why I always write a small number. Okay, I write a small number because 8, 10. 2 power 10 means 1024. Easy to remember. 0 to 1023. Second wire is called read. If this microprocessor makes this as a 1, then memory understands, hey, this guy is writing. Then there is a wire called read. See, please understand here, everything they write in a cryptic way. That is a problem here. That is why we get confused. We write as WR, read as RD, address as A, data as D. That's it. Nothing great about it. So don't get confused about all this naming convention. We have because you know that we engineers, I wanted to save my time. I want to save my time. Now, here, data. I can write or read. This only is bidirectional. But please understand, the very first microprocessor designed by Intel, 404 in 1970, where this is Core i9. In 2022, what you buy a laptops and everything. Okay, all are doing same. All are having only thing is, instead of 8 wires, somebody may have 64 wires. Instead of 10 wires, somebody may be having 40 wires, because I can address more memory. That's all, nothing more than that. So please understand. And there's only one read, only one I. See, please understand, this microprocessor can do only 2 operations. And it has internally a registers called R0, R1 up to or whatever it is, 31, whatever it is. Understand that this guy is having a 32 registers internally. I can move from any of the internal to this guy. How the microprocessor does, that is what the trick. Now we'll come to the so now I told you that the microprocessor can move, store, or he can load, 2 things. So that I have given you the 2 instructions. One is called store any register, I call RX. You can replace the X with 0 to 31, anything as you wish. That depends on the microprocessor manufacturer. Somebody may be having 31, somebody may be having 15, somebody may be having 100. Don't ask me why it is. That's the way they manufacture. And comma, the address. I can store. So this means that if I put store means I am reading from register to the memory. That's it. This the direction is this. For example, if I say, let us say that my R1 is having 45. Now, if I say that store R1, comma 831. Now what happened? This microprocessor put 831 here. How it is putting 831? I have 10 wires. Since I have 10 wires, I call these wires as A0, A1, A2, A3, A4, A5, A6, A7, A8, A9. That is 0 to 7, 10 wires. Now, in the 10 wires, there's a combination for 831. If you convert the 831 decimal into binary, okay, you will get about 512, 1. And then 256, 1. Like that, you go, if you add them, you get about 768. This is 831. Then you add one more, 128. It's more, so it does not work. 0. You learn the I told you, I'll upload the number system video, learn it, or if you already know that how to convert the binary to decimal, that is fine. That is a totally different topic. Let's not worry. But it's all, but I cannot go, I cannot store like this 1024. That is not possible, because with the 10 wires, the maximum number is 1023. Okay, now please understand, tomorrow is off day. If you could able to make your use of number system video, which I'm uploading today. I forgot to upload yesterday. I'll upload it today. That video talks about how to convert decimal to binary, binary to decimal. Please learn it. Let us not waste too much of time on this, but if somebody wanted, we can do that also. Doesn't matter. After the video, you say that I wanted to, because most of you may be knowing that. That's why I don't want to waste somebody's time. Now, if I do the instruction load R0 R31, comma 98, then what this guy does, he put address 98. He does not put write. He put read as 1, and from 98 line, the data maybe 36. It comes via this guy to R31. So please understand. You think that you are controlling LEDs, motors, bulbs, so many things, networking, all these things. But whatever you do, you are doing only 2 operations. Whether you write the language in Python or Java or C++ or JavaScript, all are doing only these 2 activities of writing to memory, reading from memory. You'll be very surprised. That's what the bottom level. So the microprocessor can do only 2 activities outside. Please remember this. If you don't remember this, then the whole thing is going to get confused. Also, the microprocessor does another activity is this. That is, this is the process. This is register R0 to R31, small memory. I give a name called R0. Now, I told you, no, plus 7546. No, he does not understand. What this process unit does is, you have to give him like this. Hey, add R0 plus R1, put the result in R2. Understand now? He will take from R0, he will take from R2, he will perform the addition. Then, for example, let us take an example. In R0, if R0 is having 41, R1 is having 36. R2 is having 25. If you tell him R0 plus R1 is R2, what our man will do, this process, he takes from here 41. He takes from 36. Both are coming here. So he will add 41 plus 36. What is it? He got 77. Then he write the 77. Our man write the 77, who the ALU, into R2. I can do anything. I can say R5 plus R7. Put the thing on R25. R3 multiply by R6. Put the result on R15. Any combination. That's all. You don't do. You only your imaginary is a combination. I can, for example, I can do like this. R6 divided by R2. Put the result in R3. I can do that. R7 and R8. Put the result in R1. Okay. I can do that. R3, R with R1, put the result in 26. Then I can also say that and of R2, put the result in R13. So you understand now. That is, I've used addition, subtraction, multiplication, division, but please understand, this guy never, this process unit ALU never talk to the external unit. All the things have to come to my local RAM, sorry, local memory, a register. So your local memory is called register and external memory is called memory. When I use memory, that is external. When I use register, that is called internal memory. So this is the symbol of and. This is a symbol. Or this is symbol. Not this is symbol. That's why I use the C symbols. Like addition, subtraction, we have symbol. We have a symbol for all the operations. I told you we will discuss about 7 operations first. Then we will discuss about other operations. Now, everything is done, man. Now you know that microprocessor does 2 operations. Internal to process. External storage. That is read and write. That's it. The microprocessor can do with outside write or read, 2 operations. Internal, it does process. It does not process with the external memory. It has to come always to this. Okay. But now you learn what microprocessor can do. Now microprocessor know how to do things. But the only problem is the microprocessor does not know what to do. So please understand the confusion between these two. How to do and what to do. You have a wonderful servant. You have a wonderful servant who knows how to do things, but you should tell him what to do. Then he will do that. How do you tell him is a trick. Once you learn the trick, how to get the work done by the microprocessor or your servant, you are the best manager, man. You are the best manager, okay, or a best boss. That's what the trick here. That is what exactly the thing. You know that now in a car, I have brake, I have a gear, I have a clutch, I have an accelerator, I have a steering. You know that all of them. And you know each one is performing its own activities. So anybody who in the car, anybody applies the brake, the car is going to stop. And anybody applies the gear, it is going to change. Anybody give an accelerator, the car is going to move faster. And anybody is a steering, God is going to turn. And what is the difference between beginner driver or novice or expert? What is the difference between them? That is what the trick here also. This microprocessor knows how to do. But if you give him what to do, then he is going to do. He does not differentiate whether it's Balaji or whether it's Vallabh, whether it's a Pratik or whoever it is. This guy does not know. He is going to do what you say. He is a simple machine. That's it. But how we are going to give it, that is what we are going to see in our next session. Okay. So this I have given a very small introduction about what is microprocessor. Am I right?